Switch location. Okay, 404.8a says the maximum height switches or circuit breakers used as switches is 6 feet 7 inches measured from the center of the handle on the on position. So maximum height here, right there, there. Now there's no minimum height, just the maximum height of the switches. So here's a switch. So you can have it right on the ground. You can have it placed, low as you want to. Just maximum height. Busways, there's an exception for busways. Clearly, busway can't be 6 feet 7 inches. So that can be above that. Brian?
Well, it's another one of those moments where my code life is flashing before my eyes. I knew this applied to disconnect switches. I knew this applied...
Which one?
Previous. I knew this... one more, sorry. I knew it applied to breakers, main breakers, overcurrent devices, but I never thought about a light switch.
Neither did I.
So you're telling me I can't install a light switch over 6 feet 7 inches if I want to?
I don't know. Let's look at 404.8a. Let's see if there's a reason all switches, circuit breakers used as switches shall be located so that they're operated from a readily accessible place, okay? So you can get to it. Shall be installed such that the center of the grip of the operating handle or the circuit breaker when the height position not one. Okay, give me an example that you have a problem locating a switch above that.
Well, there's a lot of times that we've had customers just ask us, hey, I want this out of reach of the kids or whatever the case might be. Can you put it up higher? And so we did. Never even worried about how high it was.
Does that make sense, though? I can see that you'd want to switch above 6 foot 7 inches. I mean, not that you need to have a switch above 6 foot inches.
Not talking every switch, just like, a switch here or there.
No, I can see where, let's get it high enough so that, you not have kids jumping in school or other applications, or you want to have a switch high enough. Just put this as a public input and let's see about adding an exception. Because if the switch is not being used, watch this, guys, watch this. I question the value of even specifying in switches the height of switches. Let me tell you what I'm saying. I question the value that in switches. I think the location of the height of a switch should be there when there's an issue, such as the disconnect for a motor shall be the disconnect for air conditioning equipment. In other words, where a switch is being used as a disconnecting means, right? Then we're concerned about being able to get to that disconnect. I don't think it belongs in this catch-all of all switches have to be no higher than 6 foot 7 inches. The circuit breaker. Well, if you don't want the circuit breaker higher than 6 foot 7 inches, then because it needs to be readily accessible and it shall not, then I think we need to take this text and place it in the rules for overcurrent devices in 240, into motors and air conditioning, electric spacing equipment. Where the height is a factor, it should be applicable, not like what you just said. We have this broad conversation. Even though I want to do something, it's not a disconnect. I want my light to be controlled by high location. Okay, brilliant. Okay, thank you. Got learned on that one. Okay, now, again, I'd rather this rule be contained. If this is air conditioning refrigeration equipment, I'd like to have the rules on air conditioning refrigeration, the location of the disconnect, identify that it shall not be any higher than 6 foot 7 inches, except where it's located adjacent to the equipment that it's supplying. Then in this case here, it belongs there. So this rule needs to be peppered where the rules belong, not a general rule that then prohibits applications. Okay, let's take a look at the voltage between devices. Now, here we have two 277 volt switches, line 1 and line 2. The code says that the maximum voltage between adjacent devices cannot exceed 300 volts. Or they can exceed 300 volts if an identified barrier is securely installed between them. So if you put a barrier here, then you can have a 277 volt switch here and a 277 volt switch here. If you didn't put the barrier, then because it's 480 volts, that would be a violation. Brian?
Well, I've got a question. Where did 300 volts come from? What is that?
You're talking about the max voltage between adjacent devices. Been doing this 41 years, seen a lot of people, been a lot of applications, read a lot of historical documentation. I have no clue. The only thing I can suggest No, I can't even suggest anything. All I know is it is 300 volts, and that's what we have to work with. Now, the easy thing though is this. Anytime you have 277 480 volt systems, and you have multiple switches in the box, I don't care what the deal is, you have to have barriers between all the switches.
Right.
No matter what.
But
because, see, you have 277. Look at the next graphic here. So that case is 277. What about if I have a 120 and 277? Well, the voltage between the 120 and the 277 could be as high as 381. It exceeds 300 volts. So therefore, I'd have to have a barrier here. So look at this. 120 and 120 would give you 240, you're fine. 120 and 277 gives you 381, you're not fine. 277 gives you 480, you're not fine. So whenever you have a 40 volt system and you have to have barriers between the switches. Now, the rule said between adjacent devices.
Right.
So it could be a switch and a receptacle. So the same thing applies here. The voltage between adjacent devices shall not exceed 300 volts. You're fine unless you get into 480 volt systems. Right.
But I could have a 2-pole switch with a 480 volt circuit coming to it, and it's not a problem that 480 is on a single device. I just can't have it on adjacent devices.
Right. You can't have two switches.
Okay.
One switch 480 is fine because it's a single switch.
Okay.
You just can't have it on two.
That makes perfect sense.
Eric,
You're saying 480, I'm getting confused. It's 277, right?
when I meant 480 volt systems.
Right, because I was doing some research and I was looking for 480 volt switches that I could use for motor control circuits. Could not find one anywhere.
Yeah, because it's 277
Right.
line. That's a line. That's your slash voltage rating.
Right.
All right. Now this just without getting into details, Eric. This is the 120 volt phase that we're going to be looking at, and this is the 1 volt, the 277, would have given you the maximum between the 277, and we'll mark this down as 120. And the difference between this instant point and this instant point, we'll make sure we touch those two instant points, is 539 peak volts, and RMS voltage is 70.7% about of that voltage, gives us a 381 volts. And that's why back on this graphic here, we're showing that if you had a 120 volt circuit on the secondary of a transformer, and then you also had a 277 volt circuit on the primary of the transformer, the voltage between the primary and the secondary could be as high as 381. And you can get voltage between the primary and the secondary. That is a fact. I thought it was 0, and it is wrong. But if I remember right, you could go from one phase, seemed like there was some, of course the voltage would be all different, but the maximum was 381. But I think there was, I'm not going to say anymore. There's just a difference in voltage between the two. Multi-pole snap switches. Now let me just kind of describe what this is here. We have a 120 volt circuit, and then this is red is the switch leg here, and then 277 volt circuit, and we're switching this, and the purple is going to be my switch leg. You say, well, why would you switch 120 and 277 on the same switch? Brian, you want to give us some examples where, and I've done this when I was a contractor.
Well, there's a lot of reasons why you would want to, but the one that's probably the most common is in restroom areas. You'll have a men's and women's bathroom sharing a single exhaust fan for exhaust, but you want the lights to be switched separately. So that if the lights are turned on in either bathroom, the exhaust fan runs, and when the lights are turned off, the exhaust fans are off. Maybe with some energy codes now needing occupancy sensors, this may be less of a problem, but that's a very common application.
Well,
still.
I had a commercial building, 277 lighting, 120 volt fan. I put a 2-pole rated switch, for 277 rated 2-pole switch, and I was fine. But then the code says, listen, you can only do this if the switch is marked as a 2-circuit or a 3-circuit. Now watch this. This is one circuit. This is another circuit. But then we have a problem, guys. Back on 210.7, it said back there that anytime you have more than one circuit on a device, that you had to simultaneously trip, or rather simultaneously open that device. So you can never, ever have this application because this is coming out of one panel. This is coming out of another panel, in the case of 12277 like this here. Or you could not have this one panel A, 120, and another panel B, 120. So this practice has not been permitted for many cycles.